Hello students. So we are moving to the last semester of your course, that is the fourth semester. So in this semester you have to study two papers, and in the first paper is the advanced materials. So in that I will be dealing with smart materials and myself Arunima. Okay, so we can start the class. The topic is smart materials. Okay, the word smart is actually very familiar and we are using quite often. Okay, so what is meant by a smart person? When we are saying a smart person, he or she has the ability to think wisely, to decide wisely, and he or she must be self-reliant and independent, and he or she can make timely decisions, timely action, or timely words. And sometimes this smartness is used in a negative way. Sometimes, but quite often we are using the smart term or the word smart in positive senses. So this type of behavior, that is self-reliant and decision making and responsive, and all these properties, we can say that properties, okay, or all that behavior can also be imparted by certain materials, and these materials are called smart materials. Okay, so you have to study a number of smart materials and their behavior. So now what we will look into, what is meant by the smart materials, or what are smart materials. A smart material is an object that holds a property that is susceptible to change with the introduction of an external stimulus. That is, whenever we are applying an external stimulus, it should respond or it should react. So such materials which can react or respond to the external stimuli are said to be smart. The change must be either tangible or visible. That means the changes in most of the cases we can measure the changes, so we can visualize, so we can see the changes as a function of the external stimuli. That means we are giving an external stimuli, that is anything, that means a change to the system, and the system responds. So that response, or the materials which are responding to the stimuli given, are normally termed as smart materials. And these changes can be electrical changes, that means we are giving electricity and they are giving some sort of responses. Or it can be chemical, that means we are adding some chemicals, or we are changing the chemical structure or something like that. So it can also respond to such chemical changes, then increasing or decreasing the temperature, and also we are giving some mechanical stress, and we are introducing them to the some magnetic field. All these can change a material's property. Okay, so such materials which can respond to changes such as electrical, chemical, thermal, mechanical, or magnetic are called smart materials. So we can define the smart materials in another way. That is, it can be defined as materials that sense and react to environmental conditions or stimuli such as heat and temperature, that is called the thermal changes. Then pH values, that is by changing the pH of the material, we are introducing some pH changes in the solution or something like that, it can respond to that. Okay, then chemical and ionic strength, then electromagnetic radiation, normally the ultraviolet or visible light, that is we are allowing or we are exposing the material to ultraviolet or visible light, then it will give some sort of responses. Okay, then electrical and magnetic field, mechanical stress, strain and pressure, then water and humidity. So all these can change some of the properties or shape of the material. So such materials are called smart material. That means they are actually acting like a smart person. Okay, so they are usually translated as active. When we are saying that smart materials, normally they are active materials, but the most accurate term can be reactive. That is, we are giving an action and they are reacting. Okay, so we can say that the smart materials are highly reactive. Okay. Now, we have already discussed that the smart materials can respond to a change, and these can be, or the materials are able to receive information, and when a system is receiving information, we will call it as sensing. Okay, that means we are gathering some information. That means we are sensing that information. That means if we are exposed to heat, then we can feel the temperature. Okay, that is temperature sensing. That means we are sensing the change in the heat. Then second is they are able to analyze and decide. Okay, that is called the processing. If a response is given, the materials will analyze what is the response given to them, and they will decide how to respond to that stimuli. Okay, that means the smart materials are able to analyze and decide. And these properties, that is the ability to analyze and decide, we will call it as processing. And the third is they will be able to act on the decision. That is the process of actuation, or that is the process of reaction. That is, once they gather the information, that means they are sensing what is happening to them, and they will analyze, and they will decide how to respond, and at the end they will respond to the external stimuli. So that is the normal structure of the, or normal components of a smart material. So any smart material is composed of three basic components. One is the sensor, which is gathering information. Second is the processor, which is analyzing and deciding. And third one is the actuator, that makes the decision. So the smart materials, or the materials which are having the smart properties, or the study of smart materials, is considered as interdisciplinary. Interdisciplinary means it is composed of many disciplines. That means we cannot say that the smart materials belong to chemistry only, or we cannot say that the smart materials belong to physics only, or they are belonging to the IT field, or material science, or computer science. We cannot say such dependency or such belong. Okay, that means the smart materials can be a common to all the disciplines, almost to all the disciplines, whether they are in the science or in the technology. That means they have been used in variety of fields, that is in the basic science such as physics, chemistry and biology, and their advanced versions like material chemistry, then bioengineering, biotechnology, information technology, structural engineering, etc. Okay, so the smart materials are belonging to a class of materials which are having applications in the interdisciplinary fields. So now we can classify the smart materials according to the response given by them and the stimuli given to them. That is, the common type of smart materials are piezoelectric, electrostrictive, magnetostrictive, thermoelectric, shape memory alloys, photochromic, thermochromic, etc. So all these categories you have to study in detail, but this is a basic idea. That is, the piezoelectric material respond to the deformation, and the output will be a potential difference or the electricity. So the materials which undergo deformation by the application of mechanical stress to produce electricity are called piezoelectric material. Next is the electrostrictive materials. We are giving a potential difference and the materials will deform. That is called the electrostrictive. Then similarly, magnetostrictive means we are applying a magnetic field and they will undergo deformation. Similarly, the other properties and the output is given. Okay, here the photochromic and thermochromic means we are exposing them to temperature or radiations and they will give a color change. So the main advantages, now the advantages of using smart materials is their biocompatibility. So they can be utilized in the biomedical field. Then they are very simple. That is, they are compact and very simple to operate. They have, that means the usage or handling is very safe. And last one is they are good, last but not least, they are good mechanical properties. So the advantages are biocompatibility, simplicity, compactness, then safety and also the mechanical properties. and their applications are not limited, but includes smart fabrics, then smart aircraft, sporting goods, smart dust, then reducing the vibration in the helicopter blades, then robotics. Robotics is actually having the most common application of the smart materials is in the robotics. Then medical surgeries, that means the smart materials are very much employed in the biomedical engineering or biomedical fields. Security, that is as in the form of some drones or some electronic equipments, and also some safety measures. Okay, then there are so many other applications where we can use the smart materials that you will deal in the topics, that means the piezoelectric, magnetostrictive and all. So this is a common applications, and normally the smart materials have a vast application level. Okay, then even though we are saying that they have a large number of or a very wide range of applications, and they have very good properties and something like all like that, but there are certain problems with the smart materials. Okay, that means their delicacy. Whenever we are developing a smart material, normally they will be delicate. That is, they will be lightweight, and as I said, they are simple and compact. So normally they are manufactured in a lightweight manner. So they are very delicate. That is, the breakage is very easily. Then their instability. Even though they are responding to some external stimuli, but they have a sort of instability in their behavior. That means they are not responding to the same stimuli in a similar way always. Okay. Third is the diminished performance over time. That means the fresh materials are responding very strongly, but as the time is progressing, that means as the time passes, the response becomes less. Then the difficulty to incorporate in different materials, then the toxicity and also the cost of the materials. So in conclusion, we can say that the smart materials are significant, they are measurable, appropriate, result oriented and also time oriented. So we can have a short form of or elaboration of the SMART, S-M-A-R-T, like significant, measurable, appropriate, result oriented and time oriented. Okay. So that's a brief introduction about the smart material. Then we will discuss about all these things in detail in the coming classes. Okay. Hope you have understood all these things.